We will study microsporogenesis. What is microsporogenesis? Now, formation of microspores. Formation of microspores. These microspores are also called as pollen grains. It will be formed from microspore mother cell, or that is also called as pollen mother cell. Now we can write it MMC microspore mother cell, or we can write it pollen mother cell PMC. Now both microspore mother cell or pollen mother cell, they are having chromosome number 12 that is diploid, and they will produce haploid pollen grains or microspores. So this process is called as microsporogenesis, formation of microspores from microspore mother cell, that is called as microsporogenesis. So haploid pollen grains or microspores will be formed. Now look to the structure of a flower. Now it has four parts. One is called as calyx, each part is called as sepal, corolla, each part is called as petal, androecium, each part is called as stamen. It is the male part, that is the androecium. Now today we will study this male part, this is the androecium, and then gynoecium. Gynoecium having stigma, style and ovary. Inside the ovary, ovum is present. So this is the female part, it is called as gynoecium, and each part of the gynoecium is called as carpel. Each part of the androecium is called as stamen, each part of the gynoecium is called as carpel. Now go to stamen. In each stamen there is a long thread-like structure called filament having bilobed anther. Now this is anther. Now this is the structure of a stamen. Anther. Now this thread-like structure is called as filament. Question is there. Filament is attached to thalamus, and in other side it is attached to anther lobe. In other side it is attached to anther lobe. Now just look, anther is bilobed in a typical angiosperm. That is the example of a typical angiosperm is Capsella, having that is from Solanaceae or Brassicaceae family. Now just look, anther bilobed. Now this bilobed anther is having dithecous type, having dithecous type. Now it has having two theca, and it has four chamber. Each anther lobe is again having two sac-like structure or two chamber-like structure. So total four chamber-like structures in two anther lobe. So this is called as tetrasporangiate type. Tetrasporangiate type. So now we can call it in angiosperm. It is dithecous and tetrasporangiate type. But there is exception, that is Malvaceae. In Malvaceae, that is monothecous type of anther and disporangiate type. Exception, that is disporangiate type. Now just look to the anther. This anther is, now I can call your stamen. This stamen is called as, also short question, stamen is called as microsporophyll. Inside the microsporophyll, that is microsporangia. This microsporangia develops to form pollen sac. Now your microsporangia develops to form pollen sac, and inside the pollen sac the dusty structures present. This is called as pollen grains. Now we will study how these pollen grains will be formed. It is dithecous and tetrasporangiate type. Typical angiosperm, dithecous and tetrasporangiate type. It is now we can study how the anther, what is the layers of anther, what is the structure of anther. Now we will go to structure of anther. Look, what is the structure of anther? In the anther, the outermost covering is called as epidermis. It is single layer and thick layer, protective layer. It is the protective layer. This is epidermis. Just below the epidermis there is another thick layer. Inner one is much thicker, inner wall is much thicker. This layer is called as endothecium. Just below the epidermis is protective in nature, and below it endothecium. This endothecium layer, that is hygroscopic in nature. Hygroscopic in nature means it can absorb water and it can move by the help of water. Now, endothecium, just below the endothecium, there is 2 to 3 layers of middle layer. 2 to 3 layers of middle layer. Now this middle layer, your middle layer is parenchymatous in nature. It means it can store food. Now just below the middle layer, there is another layer, single layer, that is called as tapetum layer. That is nutritive in function, that provides nutrition to the pollen mother cell or microspore mother cell, that provides nutrition to the pollen mother cell or microspore mother cell. Now this is the outermost protective covering of your anther lobe. Now 2 anther lobes, they are connected by connective. This connective is made by vascular tissue, vascular strand. Now, just below the epidermis, there is endothecium layer. This endothecium layer is hygroscopic in nature. When it matures, when the endothecium layer matures, it breaks at this point. So, forming stomium. Now it will form stomium. Through this stomium, pollen grains will come outside. These pollen grains will come outside. Stomium layer, through the stomium layer. Now, when your anther matures, middle layer and tapetum layer both disappears. Now the development, how the anther develops. So the next is development of anther. How the anther develops. Now this is the filament. Anther will develop just an outgrowth. This is called anther. Now inside the anther, first, just above the anther, there is a single epidermis layer. First epidermis layer develops. Now this epidermal layer covers, this is the anther, epidermal layer covers the parenchymatous tissue inside it. Some of the parenchymatous cells in lateral side, they will form archisporial cell. Some of them develop to form archisporial cell. Now these archisporial cells, they will divide into 2 types of cells. One is called as primary parietal cell and another one is called as primary sporogenous cell. Primary parietal cell and another one is primary sporogenous cell. This primary parietal cell divides again and again, forming 3 layers. What are these parietal layer? What are the covering layers? First, it will just below the epidermis, it will form endothecium. Then second, it will form 2 to 3 middle layers, and then it will form 1 layer of tapetum. This tapetum layer is nutritive in function. Another short question is in tapetum due to endomitosis. Tapetum, look, tapetum due to nutritive in function. Ek number 1, nutritive in function. Second, due to mitosis, it becomes polyploid in nature. Polyploid means chromosome number is more than 2n. More than 2n. Endomitosis takes place. So it becomes polyploid in nature. Now, primary parietal cell is over. At simultaneously, primary sporogenous cell. That primary sporogenous cell divides by mitosis, forming primary sporogenous tissue. This primary sporogenous tissue that will modify, forming that primary sporogenous tissue that will modify, forming microspore mother cell or pollen mother cell. When I will tell mother cell, means chromosome number is 2n, the cell having chromosome number is 2n, that is diploid in nature. Now your microspore mother cell or primary mother cell, microspore mother cell or primary mother cell. Now, pollen mother cell. Now, microspore mother cell or pollen mother cell, they will divide by meiosis. Now, I will write here microspore mother cell having chromosome number 2n. They will divide by having chromosome number 2n. They will divide by meiosis, forming 4 haploid. Each microspore mother cell will produce 4 haploid microspore having chromosome number n. This process is called as microsporogenesis. This process is called as microsporogenesis. Over.